Hello and welcome back to the channel. My name is Eddie Jennings from EJSLLC.com. This video is going to be another in my RHCE practice session series where I'm going through the posted objectives from Red Hat for the RHCE exam and giving myself a bit of a self-evaluation to see if I feel like I know what I'm talking about for the objectives, which will give me an idea if I'm prepared for my exam or not. These videos are not necessarily intended to be authoritative information, nor are they really intended to be tutorials, but as I said, it's a chance for me to practice the objectives. That being said, I do try to keep the information in these videos as accurate as possible. Before we dive in, I want to thank returning subscribers for watching another video, as well as invite everyone who's watching, if you have not subscribed yet, to do so and click the bell once you subscribe so you can be notified of when new content comes available. Feel free to share this video with others if you feel it would be useful for them, and if you enjoyed the content of the video, make sure that you click like. So this video is going to work with another objective within the be able to perform all tasks expected of a Red Hat Certified System Administrator section of the Red Hat Certified Engineer exam objectives. And we're going to be looking at configure local storage, which, as you know, these objectives are really just the overall topic objectives from the RHCSA exam, since the RHCE exam builds on RHCSA knowledge. So what we're going to do, like the other couple of videos with these objectives, we're going to go through the configure local storage objectives from the RHCSA exam, but go through them rather quickly because really this should be a review rather than a deep dive for it. If you would like to see practice sessions where I go a bit slower through the objectives and do more examples and such, you might want to check out the RHCSA practice sessions that I recorded about a year or so ago when I was preparing for that exam. So getting right to it with configuring local storage, one of the first things we have to do is be able to list, create, and delete partitions on MBR and GPT disks. So I'm here with my Red Hat Enterprise Linux workstation. I'm actually going to SSH into our first lab server. So Eddie admin at lab.rel or -rel.svr01. All right, so here we are on the server. And what we're going to do to be able to practice this objective is do exactly as it says. We're going to list, create, and delete some partitions on MBR and GPT disks. So to figure out the disks that you have available to work with, there are a couple ways we can do this. One is with the ls block command, and that will tell us, what block devices we have. We have VDA, which is where everything is installed, and then I have an extra 20 gigabyte block device for VDB. Another way you can do this, I've seen folks do, is fdisk-l, and so we'll do sudo fdisk-l, feed that our credential, and that also gives us our devices and such. We see we have VDA1, VDA2, which those are the partitions for VDA, and we see we have disk VDB. So it tells us our disk and the partitions and such that are on it. So we will work with VDB in this, and we're going to start with MBR, which if I recall off the top of my head, stands for Master Boot Record, and that's a little bit older partition style, whereas in that style you could have, I think it's 3 primary partitions, and the 4th partition could be an extended partition, which can have logical partitions as many as you need. So what I'm going to do, let's see, clear my screen. I'm actually going to sudo into root, and one of the reasons I'm doing that, just for the speed of the video, to keep from having to type sudo for pretty much every command, because you're going to need to have root privileges when you are working with block devices and such. So we're going to go to our dev directory, and we can see that VDB is here. So let's see. First of all, let's list the partitions on it. So if I were to go into the fdisk program, we're using fdisk because we're going to be working with MBR, and we'll do VDB. So we're in fdisk. You can use the M key to get all the different commands and such, but we're first going to do the P key, which is going to print our partition table for this, and we currently have no partitions on this, so that's the listing part. To create a partition, we would do the C key. Oh wait, I'm wrong about that. Man, that's rather embarrassing. So let's do this. I thought it was C for create. Well, when in doubt, no, that's toggle DOS compatibility flag. All right, well, oops. let's toggle that off. And let's look at M again. Thought it was C. I know D is delete, P is print, N for add new partition. Well, I'm glad I'm doing these review sessions because I can't believe I forgot that it was N. Anyway, so we'll do N, and I'll actually walk you through a little wizard for this. And this is, if you remember, I talked about the primary extended partitions. Even though it says for free, I'm fairly sure the fourth partition the fourth primary partition is what you would be doing your extended partitions from. But anyway, we're going to do a primary partition, so P, and we're going to make this be partition number 1. We'll just keep the default. The first sector, we will keep that as default, and in MBR, the first 2 megabytes is where that partition table is living. And then the last sector, we can either do sector sizes, or we can give it a particular size that we want the partition to be. I almost always am working with the sizes and such rather than the individual sector. But if you know the exact sector that you want your partition boundary to be at, by all means, you can put it there. By default, it's going to use the entirety of the disk, but we don't want to do that because we're going to do a couple of partitions here. So we'll do plus 500 M for megabytes. And it's created a new partition and it's type Linux. Now we can use different labels for our partition. I think the L key gives us that. Yeah. So for our different labels, 83, which is what we currently have, is just for, standard Linux, right? If you were doing a partition that we're eventually going to use like FAT32 and such, then we will be using some of these other label codes. Let's see, there should be one for LVM. Yep, 8E is LVM, and there's also, if I recall, there's one for swap if you're wanting to make a swap partition. Let's see if we can find swap here. Probably you watching the video, you have already identified it, whereas I'm just trying to talk and read down the list at the same time. There it is, 82, Linux swap. All right, so let's say that we wanted this to be for LVM. I believe, I thought L was the command for that, but when in doubt, we can double check our list here. We need to add the partition type. T, that's it. Pretty sure T is what I want. Yep, and then L to see all the codes. And this is where if we wanted to, we could change it to 8E for Linux LVM. We're not going to do that for right now. I might have just contradicted myself a moment ago. We're going to keep it at 83, but the T command is what you would use for that. So if we want, we can make some other partitions as well. But for this, we're just going to go ahead and press write or W, and that writes the partition and takes you out of fdisk. Now, a good thing to do after this is run the part probe command. That will make sure that operating system has reread all the available partitions. If we were to look at ls block again, we see we now have VDB1 that is 500 megabytes. So fairly easy to do with that. And if we want to make another partition, we can simply repeat the process. I'm going to make another window actually for my terminal here, and in this window we're going to head to my second server. So SSH Eddie, if I spell my username right, admin at lab-rel svr02. Now this server also has a 20 gigabyte disk that I have attached to it. We're going to go ahead and sudo into root, go into the dev directory, and we're going to work with GPT on this particular server. So if I were to do gdisk, which is the command for that, let me just see if that's there. Command not found. You can also use parted. I've never really used parted. I'm sure it's a great tool, and I know the Ansible stuff for doing partitions is basically using parted, but I've typically used fdisk and gdisk. Not that I have anything against parted, it's just simply not the tool that I have learned. Now, one thing on your RHCE exam, and this is true for RHCSA as well, is you're able to install software. If it's in the standard repos for Red Hat Enterprise Linux, you'll have it available. So I'm going to do that. So we'll do DNF install gdisk. What am I doing? Sudo, I'm already as root. So DNF install gdisk. Probably could have done -Y to save a little time. All right, install that. And let's try this again. gdisk, and we'll do VDB or dev VDB. Now, much like fdisk, a lot of the commands are similar, except you can do question to see your commands, but we have the same P for printing the partition table. Obviously no partition tables on this. The L will list your known partition types, and so C here changes the partition's name. N is what I want for adding that new partition. So let's do that. We'll do N. Now notice we have up to 128 partitions available. That is one of the big differences between the, I think it's GUID partition table, GPT, if I recall off the top of my head. One of the big advantages of that over MBR is you can have up to 128 partitions. I think Windows you might have to, I think you can have a little less on that. I can't remember off the top of my head. But the big thing is that it supports much larger partition sizes. I think MBR, you can't have a partition over 2 terabytes, if I recall off the top of my head. It's either 1 or 2 terabytes. I think it's 2 terabytes versus your GPT partitions can be significantly larger than that should you choose to have it. So we'll keep the default first partition. And again, we can either use sectors or we can tell it the actual size, like where on the disk, for basically the size is being translated into what sector we're starting at. For the first sector, we're just going to keep the default since this is our first partition. And we are going to just make this a 500 gigabyte partition as well. Or 500 megabyte, rather. And here by default, again, Linux file system will keep that. The codes are a little bit different. They follow a similar pattern, such as if we were to find Linux LVM, that's going to be 8E00, if I recall off the top of my head for this. I'm sure it's staring me in the face, but I can't. Yep, 8E00 for Linux LVM. And let's see where swap is for that. I want to think it's 8200 for swap, Linux swap rather. I'm sure again, you watching the video probably have already identified it, and I'm still looking around. Yep, 8200 for Linux swap. And then we're just going to keep the default 8300 for just Linux file system. There we go. And to write your partition, you would do W. If we wanted to make another partition, let's say we did a second one here, default 2. Of course, it's going to start at where that last partition left off. Now, if you wanted to make non-contiguous partitions, you would be able to do that. But in my experience, I typically have done contiguous partitions. Make that 500 megabytes as well. So we'll write this. And it's going to warn you, this is going to override existing partitions. That's okay. That's by design. And just like with fdisk, you'll want to do part probe. I'm not sure if you have to do that 100% of the time, but from what I have learned, it's generally a good practice to do that. And if I do ls block, we see we now have 2 partitions, VDB1, VDB2, and both of those are 500 megabytes large. So that should pretty much cover the list, create, and delete partitions on MBR and GPT. Oh, we haven't deleted a partition yet. Oops. So let's do this, well, not do this again rather, but we'll go back into gdisk, dev VDB, and let's delete a partition. So D for delete, we choose the partition number we want to delete. Let's get rid of the second one. We have to write that with W. It's going to warn us. Yes. And or part probe. ls block. We see our partitions gone. And let's go back to our MBR VM. So fdisk, dev VDB, delete. It didn't give us an option because we only had the one partition. We'll write that. Part probe, ls block, and it is gone. So we have just the block device VDB1, and then for our server where we're working with GPT, we have, we have just the block device VDB, and then on our server where we're working with GPT, we have the one partition left of VDB1. Next objective is creating and removing physical volumes, and this is going to work with LVM or Logical Volume Manager. So for this, I'm actually going to use I'll get out of this. We'll use the server 2 because we can make some more partitions with GPT. So let's do that. So what we're going to do, we'll do gdisk again, dev vdb, new partition 2. We'll make it 500 megabytes again. Oops, I did not want to do that. So when in doubt, yeah, we can enter that, and we're going to quit because we don't want to write that. Made a mistake there. So let's try this again. gdisk dev vdb new partition 2. We're going to keep the default of, because I want to make these contiguous partitions. And now we're going to say plus 500 megabytes. And we're going to actually use 8E00 for the, to make that Linux LVM. I wonder, let's take a look at the commands. We have the T command, change partitions type code, yes. Good, we can pick the partition. So we're going to do that first partition, make that be Linux LVM as well. So we're going to make some more partitions. So in again, this will be partition 3. Let's make this one just 100. Wait, I almost made that same mistake again. First sector, yes. Last sector plus 100. And we'll do 8E00 for Linux LVM. And we'll do one more. Make it 100 megabytes. 8E00. And we'll write all of that. Part probe and ls block. So there we go. We got 4 partitions, 2 of which are 500 megabytes and 2 of which are 100 megabytes. So now we're ready to work with physical volumes. For LVM, just a brief little overview of that. You have the idea of you are going to have block devices, and these block devices are either going to be the block device itself, or they can be partitions of your block devices, such as what we're going to be working with here. LVM is going to work with our physical volumes. The physical volumes are basically your block storage. It's going to be your pool of raw storage that you, or rather it's going to be the raw storage that's used for pools. So we'll create physical volumes. And that sounds kind of weird because we're not actually making new devices, but what we're basically doing is initializing our block devices in a way that LVM is going to be able to leverage them. After that, the next step is you're going to be assigning the physical volumes to volume groups. And this is where like your little pool of storage is created. And then the last step is actually making logical volumes, which these logical volumes are effectively being a block device. And of course, we're kind of abstracted away from the original block device, but they'll be the block device on which you can create a file system and then, of course, mount that file system and go to town making and storing your files. So for the creating physical volumes, we will do pv create, physical volume create, and dev vdb1. All right, and let's go ahead and make another one, just have some fun, dev vdb2. We're going to go crazy. We're going to initialize all of them. So pv create dev vdb3, pv create dev vdb4. Now you can do pv display to see all of your physical volumes, and we see our physical volumes there. We also see some others that are used for the initial, or not the initial, but the install of the operating system. I've also seen people say PVS. Okay, that's a kind of a shorter version of being able to see your physical volumes. Cool, that's not something I've really used before. I just remember that out of the back of my head there. So we now have all of these physical volumes ready to be utilized. If we wanted to delete a physical volume, we would do pv, I think it's pv remove. Let's remove vdb4. And once you do that, it's no longer going to be a physical volume for us. Now, if you currently have it in a volume group, I can't remember off the top of my head if it'll let you delete the physical volume while it's in a volume group. I want to think no. I know that you can't kill a volume group when it has logical volumes on it, but I'm not 100% sure about physical volumes. But either way, when you're deleting stuff with storage, you should always be careful about it anyway. So we're going to make it be a physical volume again. So pv create, I just removed it to take care of that part of the objective there. Dev VDB4. All right, and it has been created. So next we need to assign these volumes to a volume group. You don't have to do all the volumes, you can do some of the volumes, and we're just going to do a couple of volumes here. So for volume group, we're going to do VG create. We need to give it a name, and we'll just call this test VG, and then we tell it which physical volumes that we want. We want to do VDB1 and dev VDB2. Tells us that our test VG has been created, and we can do VG display, which will give us a lot of information about it, and we can also do VGS, I believe, and that gives us the real condensed version of it. Tells us we have 2 physical volumes, and the volume size is just under 1,000 megabytes, but this I believe is counting megabytes instead of megabytes as far as like the base 2 versus base 10. The thing I did want to point out with our volume groups is this PE size here, and that stands for physical extent. Basically, the smallest block of storage that you're going to be working with is 4 megabytes. So let's say that you have something that is, like a kilobyte large. It'll effectively be taking, if I'm understanding this right, it'll be taking basically 4 megabytes of that block space. If I'm incorrect, by all means, as I've mentioned on any of these practice session videos, feel free to leave a comment. It'll help me because it'll set me straight, and anyone watching this, I'm sure, would appreciate the accurate information as well. You can set the physical extent size, and I believe, I'm trying to remember, is it -E maybe? So man p VG create when in doubt. Let's see, S for physical extent size. I don't know why I was thinking E. Is there an E? Let's look. -E. I guess not. Maybe I was thinking extent, but when you do the VG create, you can use -S to specify how large you want your physical extent sizes. I'd say for your home lab and such, probably defaults are going to be fine, but you wouldn't be able to configure this stuff if there wasn't a need for it somewhere along the way. So the last step is making a logical volume. So as the pattern goes, we'll do LV create. This is going to be a little bit different. So for LV create, we have to specify a couple of things. First of all, we need to give it, I think it's just -n name. We're going to call this test LV. We need to give it a size, and there's a couple of ways of doing this. You can do -l and tell it the number of physical extents. Our volume group here, our test VG volume group, has a total of 248 physical extents available to it. Something just occurred to me. I think when I was talking about physical extent size in that kilobyte example, I don't think I was correct with that. I think this is dealing with how you can carve up the volume group to give to the logical volume. For example, we cannot have a logical volume smaller than 4 megabytes. And whatever the size of the logical volume is, it's going to be in terms of number of physical extent. So you're not going to be able to have like a 7 megabyte logical volume. You would have an 8 megabyte logical volume. So that's what I meant by that. See, that's why you do the review session. Something that you will probably notice in your own practice sessions is when you're having to talk through this and you're explaining it like I'm doing on this video, or you're just kind of doing it for yourself, there will be things that you forget that as you're talking about it, you're thinking about it and you'll remember them. And also there will be some things that you'll kind of see the pattern of how things fit together, which having that pattern in your head will help you remember that more on your exam. But back to the task at hand here, making our logical volume. So the lowercase l, we can say the number of physical extents that we want to use for this. You can also do something such as 50% free, and say, whatever the space that's available, we want to give 50% of the free space to this this logical volume. Or you can do the capital L, and that capital L, we can either give it a number such as 100 megabytes, or let's say that it already was 100 megabytes. We wanted to add 100 megabytes. We can do plus 100 megabytes, and I think you can shrink it as well, if I recall off the top of my head. But we're going to say, and right now it's 0, right? So we're just going to say plus 100 megabytes. Then we have to tell it the volume group to put it in. And this, I can't remember if I can actually give it just the name of the volume group or if I have to give it the path. So we'll try just the name and let's see what happens. Famous last words in IT, right? Ah, it did it. Excellent. So now LV display gives you a good bit of information, or LVS for the quick version of it. And we see that we have a test logical volume on test volume group. The other neat thing now, LS block, we see that our logical volume appears with LS block. Now, the other thing, we have to delete logical volumes, just like you have VG remove and all that, you have LV remove as well. We're not going to delete this yet because we have a couple more objectives that we want to touch with this, and then when we're done, we'll delete everything. So the next thing talks about configuring systems to mount, configure systems to mount file systems at boot by universally unique ID or label. So this is dealing with mounting our file systems, which kind of a brief overview of that. You take a block device, for example. We now have a block device that's an LVM volume that is 100 megabytes large, and you take that block device and you format it with a file system. This can be an XFS file system, ext4. You can start doing the more advanced file systems like ButterFS and ZFS, neither of which I've really used that much. At some point I'm going to dive into that, but those file systems can be used to manage the whole block devices and such as well anyway. So, but for lack of a better phrase, traditional file systems, that'll be your ext4s and XFS and such. On the Windows side, well, actually you can do NTFS and Linux as well, but on Windows you're primarily going to be working with NTFS. Sometimes you'll be working with FAT, and you'll be doing that with either exFAT and vFAT. But the point being, block device is then formatted with a file system. Once you have that block device formatted with a file system, the next step is mounting it to a directory. In the case of Windows, these mount points are usually C:, or D:, or F:, all that kind of stuff. In the Linux world, it can be anything, and I'm pretty sure you could probably mount a block device to any other directory in Windows. I've never tried it before, but here we are in the Linux land though. So we're going to make a directory. We're going to put it in the MNT folder, and we're going to call it XFS test. So if we wanted to take this block device here, this test LV, and make it and format it with the XFS file system and then mount it to this particular mount point, here's what we will do for that. The test LV, if we were to go back and look at some of the details here, that is the actual path to test LV. There's a couple other ways of doing this, but what we need to do, I'm going to copy this path here, and we're going to do the makefs command. Now, makefs, you can specify file systems either dot whatever, or I think the -t flag will work with that. Let's take a look at the man page real quick. I think it's -t for type. Yeah, you can specify the type that way, or we can do makefs.xfs, and that's basically makefs-t xfs, and we'll put the name of our block device. And that's it. So we now have LS block. That basically stays the same. We now have a file system on that. So to be able to get the UUID that it's talking about, I like using block ID. And block ID is going to give us the UUID. This is our file system that we have there. Now, if we just wanted to mount this kind of one-off, you don't need the UUID for that. We could easily do mount, and we're going to see if I can remember this. This is one of these things like tar and link or ln command. I'll get some of the stuff backwards, but I believe we are going to do mount and the device. So dev vd or dev test vg test lv, and we'll mount that to xfs test. I think that's the order that I want. No errors. df-h, show you your mounted file systems, and there we go. So we have mounted, and it translates that to the dev mapper stuff. But so we've mounted our file system. Problem is that is not going to persist. What we have to do to make our file systems persist is to edit the RHCSA tab file. So I'm going to unmount this, because we're going to use fstab, and I'm going to show you a little trick that'll save some time for your test. So we'll vi etc fstab, and we see some file systems here. So let's go to the end of the file. We're going to add a line, and we actually aren't going to do this by UUID or label yet. I'm going to show you another way of doing this. I recommend using UUID, but just for completeness, you can basically do what you did for your mount command. So dev test vg test lv. We have to tell it where we're mounting to, and these are space delimited. You also delimit it with tabs as well. XFS or MNT XFS test. We have to tell it the file system that we want. We tell it what options to use. We're just going to use defaults. When you're starting to work with video and stuff, you would have to put some other things here in addition to defaults. The 0, if I recall correctly, what's the first 0? You can look up the man page for RHCSA tab and it will tell you, but one of them is when you are running the FSCK to check these particular file systems, and I think it's the order that you want to check those file systems, and the other deals with like memory dumps, I think, but don't quote me on that. All right, so the way that you can tell without taking the time to reboot your system if your mounts are going to persist, put it in FS tab and then do mount-A. What that does is read RHCSA tab and then mount everything that it can. So if we do df-h, we see that our file system is mounted. So let's go back to RHCSA tab, and we are going to delete this line. I'll use DD for that. Now, one other little trick I want to show you. Let's say that you're in a situation where you're not working in a terminal window like this that's in a GUI environment, but you're literally on the console where you don't really have copy and paste. One thing that I do to get my UUIDs to do that in VI is go into command mode, :R, which says whatever command that you run, write the output to that into your VI document. Exclamation point says we want to run a command, and block ID. And there is all of block ID. So if I want it, I'll just delete these lines here. And notice that it gives you the device, which we're not going to use because we have the UUID. And I've seen UUID work with and without the quotation marks around it. But we get our UUID, which is how if I'm adding something to the RHCSA tab, I almost always use that, because there's a chance if you use the device name like you see up there with root, that there might be something else that gets that name. UUID, that's not going to happen. So we are mounting it to mount XFS test. It is an XFS file system with the default options 00, mount-A, df-h, and there is our file system. Now the other thing it talked about was using a label. So we made our XFS file system with makefs. I'm curious, let's take a look at the man page real quick. I know how to add a label, but I wonder if we can do a label at this time with that. Yeah, let's take a look. Man, makefs, xfs. Can we tell it a label at the time of doing the file system? Yes, it looks like we can. Oh, sweet. You can do -L at the time of making the file system. Otherwise, you have to use, I think it's xfs admin. Yeah, all right. So xfs admin is, you can do a couple of things with that. I believe you can, one of us, like xfs growfs. There are a couple of things you can do with xfs admin, but the thing that I've used it for is adding a file system label. Now I just discovered I can do that when I make the file system. But a label is similar to how UUID works. You would hopefully be giving that a label that, you know, kind of is human readable in the fact that, oh, this file system is for holding this type of file, and it can be used for mounting. So let's do xfs admin and -L, and our label, we're going to call it xfs test. And the file system that we're putting that to is dev vg or test vg test lv. Notice I'm not saying to the mount point. I'm saying we're doing this to the actual file system, which is on that block device. Did it complain? Oh, it has a mounted file system. Oops. So let's unmount mnt xfs test. Let's try this again. There we go. All right. So I forgot you cannot change that label while the file system is mounted. And I guess that makes sense why you would do that. If we were to do our block ID again, we see that in addition to UUID, we now have a label XFS test. And just like using UUID in the FS tab, as the objective tells us, we can use the XFS label, or the label that we have here, which is XFS test. So if I were to VI into /etcfs tab, or actually let's do DFSH real quick, just show you that that's not mounted anymore. VI /etcfs tab, and we're going to go and delete the UUID. Go back into insert mode, and we'll paste the label. And mount -A, df-h, and there is our file system. So we can, and the whole reason, again, we're using FS tab is, /etcfs tab, is the fact that any configuration you do on your exams, RHCSA, RHCE, and I imagine this is true for the exams you would take to get to the RHCA, you have to be able to make all of your configurations persist. And the way we do that with our mounts is by putting that into the /etcfs tab. So the last objective here under the configure local storage is adding new partitions and logical volumes and swap to a system non-destructively. All right, so non-destructively means we can't lose any data. So let's do that. Let's make another logical volume. So we'll do lv create name, and this we're going to call this, just to mess with it, we'll do ext4 test, and we're going to make this, we'll do 200 megabytes, and we're going to use that test vg again. All right, LVS, we see our ext4 test is there, so we have just added a logical volume, and we have done that non-destructively. Obviously that did not destroy anything. And I'm just curious, since XFS had this, I wonder if ext4, you can do the label at the time as well. Maybe 0-L. ext4 and XFS almost have the exact same, yep, new label volume. Awesome, we'll do that. We'll put that to the test here. So let us, let's put a file system on that, just see what happens here. So makefs, ext4, the device, which is going to be dev test vg ext4 test. And we'll go ahead and do the label. We'll call it ext4 test. All right, block ID. Yeah, it did it. Sweet. And so we could rinse repeat to, except with /etcfs tab, we would say ext4 obviously rather than XFS. Now let's make another logical volume and use it for swap. So LV create name, we'll call it swap test. And we're going to do another, let's see. I think we have, well, do we have the space for that? No. So we did what? Let's just do 50 megabytes here. And again, test VG is the volume group that we're using. LVS. All right, so we have our swap test. Now to initialize your swap for this, I got to remember this. I know swap on, swap off will, I guess that's all I need. And then swap on -A reads at CFS tab. But I thought there's a make swap. Yeah, pretty sure there is. Yep, make swap. Okay. Because I remember it's kind of like a file system. You have to put the file system on the block device, then you can, mount it to stuff, and swap is similar with that. So we're going to make swap. I don't think there's any options we need to use for that, but we'll find out. And we'll do dev test VG swap test. All right, so we now have our swap, and we can do swap on dev. Oh wait, let's take a look. Free dash MH. All right, so we currently have 2 gigs of swap available. So swap on dev test VG swap test. All right, free dash MH. What? Oh, it's probably because it's just 50 megabytes. Grumble. I was expecting that to seem much cooler. Okay, so let's do this. Swap off dev test VG swap test. All right, and I'm not sure. Let's take a look at make swap. Maybe there's a way to unmake the swap. I guess not. We'd have to just have to blow it away. Well, what should we do for this? I want to make this larger. Let's go back to LV. I think LV extend is what we want. Yeah, LV extend. So name. Now this, I don't think I can just do swap test. Yeah. So we need to do dev test VG swap test, and we are going to see -L add, I think I have space for this, 500 megabytes. Okay, so now it's 552. Now let's do this again. We're going to make swap. I think I have to do this again. Dev test VG swap test. All right, good. 5. The size there. Let's try swap on again. And free dash MH. There we go, 2.5 gigabytes of swap. All right, so now it worked before, but I wanted to be able to actually see some, I guess if we did the non-human readable, we would have seen it. Anyway, so it's there. So we'll swap. I'm just going to press up because I'm lazy at the moment. We're going to swap off. All right. And let's see. Swap on. There was another command for swap. Or at least I thought there was. Swap label. Nope. Just swap on. And swap on. I thought there was one that. Oh. Swap, not SPA. I thought there was one that would just label or tell you what you have available. I guess not. All right, so block ID. There's our swap that we created. So let's take this UUID here. Copy that. VI at CFS tab. And we are going to permanently, or I guess persistently, UUID equals, paste that in there. We don't have to, for this, we have, do we have to put none? I guess we did. I think I just did swap for that rather than none. Let's try swap. Worst thing that'll happen is that it doesn't mount. Defaults 0, 0. Now swap, let's see, free-mh. All right, swap on -a, just like mount -a. This is going to read from RHCSA tab. And let's see if it mounted. Yes, it did. So swap is what I remember using. I guess none swap would work as well. But that would do that persistently. So let's see. Now we need to delete logical volumes. We want to go back and do that. So LVS. Now, what I'm going to do is swap off dev test VG and then swap test. So it's effectively no longer mounted. Let's see. LSMNT. All right, so we just have XFS test. So let's umount MNT XFS test. All right, so now we can start deleting our logical volumes. So LV remove. We give it the path X. Let's see, test VG. We can do some tab completion here. By the way, if you don't have tab completion on your exam, you can install, I think it's bash-completion. I think it's the name of the package, and that'll give you your tab completion. And it's going to ask us, are you sure? And yes, we're sure. So let's get rid of swap test as well. Yes, I'm sure. Let's get rid of test LV. Yes, I'm sure. We can do the same thing for volume groups. So that would be VG remove, test VG. It's gone. And then we did removing of the physical volumes a little bit earlier. So I know this was quick. This is kind of a whirlwind through these objectives. But again, this part of the exam is really, I think Red Hat assumes that it's a given for you, such as if you're taking RHCE, you should be fairly familiar with these topics. So I would say a good test for you as you're preparing for your exam yourself is if you feel confident enough to just kind of know what to do on these, kind of like how I've done versus, having to dig into man pages for every single thing and not knowing what's going on, such as there was another video. I couldn't remember. It was like the two doing file redirection for some standard error stuff that I struggled with in the video, so that'll be something that I look at again. If there was something in here like that, then I will spend a bit more time on it. But if you yourself, when you're preparing, can kind of blow through these like I have, then you're probably pretty well prepared for the exam to tackle any of these objectives. As always, I want to thank returning subscribers for watching another video, as well as invite anyone who hasn't subscribed yet to subscribe and ring the bell when you do, so you can be available. So you can be available. Can you tell I've said that a few times before? So you can be notified when new content is available. I want to thank you for taking the time to watch. I know these last videos especially tend to be long, but again, it's just a chance for me to help prepare for the exam and maybe help you with your own preparation. If you enjoyed the video, make sure you do click like and feel free to leave comments, questions, and such. I'll answer and respond as I have time and ability, and I will see you the next time.